Hello everyone. In this tutorial we will solve a question based on the overlap safe method. Now here we are given an input sequence, we are given the impulse response of the filter, and we are told to find the output sequence by using the overlap safe method. Now first we find the value of m. Now m is the length of the impulse response of the filter. So there are three elements in the impulse response, so we can say that the length of impulse response, that is m, is 3. Then we assume the value of L to be 2. Why do we assume this value of L? I'll tell you this later. And the value of N, that is the length of the input data blocks, is given by this formula L plus m minus 1, which is equal to 4 over here, because the value of L is 2, m is 3, so 2 plus 3 is 5, minus 1 is 4. Now why do we form the input data blocks? Now we see that the input sequence that is given to us in the question is very long, and the calculations actually become very tedious when you have the input sequence very long. So what we do is we divide this input sequence into input data blocks of shorter length, and then we calculate the value of output data blocks for each input data blocks separately. Now how is the input data blocks represented? So this is the input data blocks, and the first few elements will be the last m-1 segments from the previous data blocks, and next L samples we will take from the input sequence. Now why I have taken the value of L as 2? Now if I take this value of L as 2, what I see is I get 7 input data blocks which is having a length of 4. Now the length of the input data block is very small, and we can apply the circular convolution and we can find the value of output data block. If I take the value of L as 3, I can take the value of L as 3 or 4 also. But what happens is if I take the value of L as 3, so this will become N is equal to 3 plus 3, which is 6, 6 minus 1 is 5. So the value of the input data blocks will become, 5, and I will get at least 5 input data blocks. If I take the value of L as 4, so this the value of N will be 4 plus 3, that is 7 minus 1 is 6. So the value of the length of input data blocks will be 6, and I might get 3 or 4 input data blocks. Now I see that this input data blocks is actually, it is increasing, the sequence is increasing. So again the calculation will become pretty tedious. So I take this value of L as 2, and if I take the value of L as 1, I see that the value of N, that is the length of the input data blocks, becomes L, that is 1 plus 3, 4 minus 1, that is equal to 3. So the length of the input data blocks will decrease, and it will be easy to calculate the output data block. Now let us start. So the first input data block, so first I have to place the last m-1 segments from the previous data blocks. Now for the first input data blocks there is no previous data blocks, so what I have to do is I have to first find the value of m-1. Now m over here is 3, so m-1 is 2. As it is not having any previous data block, so I'll pad 2 zeros. So as the value of m-1 is 2, so first I'll place 2 elements. So first I'll pad 2 zeros, as there is no previous input data block for the first input data block, and then I have to place L samples from the input sequence that I am given in the question. Now the value of L is 2, so I'll take two values from x of n. So 1 and 2 first I'll take. So I have found the first input data block, and the length of it is 4. Second, now I have to take the last m-1 segments from the previous data block. So the last m-1, the value of m-1 is 2. That means I have to take the last 2 values from the previous input data block. So the last 2 values is 1 and 2. So 1, 2. And then I have to take the L samples from the input. Now the value of L is 2, I have assumed it to be 2, so I have to take 2 samples from the input. So I'll take now minus 1 and 2, minus 1 and 2. Then the third input data block will be, again, first I have to take the last m-1 segments from the previous input data block. So the previous input data block for this is x2 of n. So the last two m minus 1 segment I have to take, that is minus 1 and 2, and then I have to take L samples from the input sequence. So I'll take the next two samples, that is 3 and minus 2. Then the fourth input data block, again first I have to take the last m minus 1 segments from the previous data block. So from the previous data block I have to take last m minus 1 segment elements. So m minus 1 is equal to 2, so the last two elements I have to take, so 3 and minus 2, and then I have to take L samples from the input data that I am given in the question. So the next two L segments is minus 3 and minus 1, so minus 3 and minus 1. Then next input data block, again I have to take the last m minus 1 segments from the previous data block. The previous data block is over here, and the last m minus 1 segments are minus 3 and minus 1, as the value of m minus 1 is 2. So last two segments I have to take minus 3 and minus 1, and then I have to take L samples from the input data that I am given in the question. Now the value of L again is 2, so I'll take two elements from the input, that is 1 and 1. Then next again I have to take first the last m minus 1 segments from the previous data block. So the last m minus 1 segment from the previous data block over here is 1 and 1, as the value of m minus 1 is 2. That means I have to take last two segments from the previous block, so 1 and 1 I am going to take, and then I have to take L samples from the input, that is 2 and minus 1. Then next again I'll take last m minus 1 segment from the previous data blocks, that is 2 and minus 1, as the value of m minus 1 is 2. So last two segments I have to take from the previous input data blocks, that is 2 and minus 1. And now I'm done with the input sequence. So what I'll do is I'll pad two zeros, and I'm done forming the input data blocks. Now we have found the value of each input data blocks, and also we are given the value of impulse response in the question. Now we will find the value of output data blocks for each input data blocks by using the circular convolution. Now we will use one sequence and we will circularly shift the samples of that particular sequence. So we will consider that sequence to be h of n. So the output data block of first input data block will be, we will circularly shift the samples of the impulse response. So the samples of impulse response is 1, 2 and 3. Its length is 3, but the length of the input data block is 4. So we have to make the length of impulse response equal to the length of input data block. So we will add one more 0, 1, 2, 3, 0, and then we will circularly shift the samples of this h of n. So this becomes 0, 1, 2, 3, 3, 0, 1, 2, and 2, 3, 0, 1. Then we will multiply this with the first input data block. So 0, 0, 1, 2. Now we have to perform the multiplication, that is rows into column. So this is 3 plus 4. If you multiply this second row with this column, so this becomes 6. If we multiply this row with the column over here, so this turns out to be 1. And if you multiply this row with this column, so this turns out to be 2 and 2. So 2 plus 2. So the value of the first output data block is 7614. Similarly, we have to find the value of the rest of the output data blocks. So the second output data block will be, again we will circularly shift the samples of h of n, that is the impulse response. So 1, 2, 3, 0, 0, 1, 2, 3, 3, 0, 1, 2, 2, 3, 0, 1. And the next input data block, that is second input data block, is 1, 2, minus 1, 2. Again, after calculating this, we find the value of the second output data block to be to 10, 6, 6. Now we will find the value of third output data block. So the third output data block, again we will circularly shift the value the elements of impulse response, that is 1, 2, 3 and 0. So 1, 2, 3, 0, 0, 1, 2, 3, 3, 0, 1, 2 and 2, 3, 0, 1. And then we will take the third input data block, that is minus 1, 2, 3 and minus 2. So minus 1, 2, 3 and minus 2. If we solve this, we get the value of it as 4, minus 6, 4 and 10. Then the value of fourth output block is, again we will first circularly shift the samples of impulse response. So 1, 2, 3, 0, 0, 1, 2, 3, 3, 0, 1, 2, 2, 3, 0, 1. Then we will consider the fourth input data block, that is 3 minus 2 minus 3 minus 1. So 3 minus 2 minus 3 minus 1. If we solve this, we get the value of the fourth output data block as minus 8, 1, 2 minus 13. So minus 8, 1, 2 minus 13. Then the output of fifth input data block will be, again circularly shift this, 1, 2, 3, 0, 0, 1, 2, 3, 3, 0, 1, 2, 2, 3, 0, 1. The fifth input data block is minus 3 minus 1, 1, 1. So minus 3 minus 1, 1, 1. So if we calculate this, we will find the value as 2 minus 4, 2 minus 4 minus 10, 0. Then the output of sixth input data block will be, again we have to apply the circular shifting of the samples. So 1, 2, 3, 0, 0, 1, 2, 3, 3, 0, 1, 2 and 2, 3, 0, 1. Then the sixth input data block is 1, 1, 2 minus 1. So 1, 1, 2 minus 1. So if we calculate this, we find the value of sixth output data block as 5076. 076, and the output for this last input data block will be, again apply circular shifting of the samples of the impulse response, 3012 and 2301. And the seventh input data block is 2 minus 100, 2 minus 100, and the value of this is 224 minus 3. Now we have successfully found the output data blocks for each input data blocks, and now we have to find the final output, that is y of n. So the final output y of n is obtained by discarding the initial m-1 samples from each output data blocks and then by connecting all output blocks one after the other. So here we will discard the initial m-1 samples from each output data block. So the value of m-1 in this question was 2. So we will discard the initial 2 samples from each output data blocks, and we will consider the rest of the samples and we will join them. So for the first output data block, we will discard 7 and 6 as these are the initial 2 samples, and we will consider 1 and 4. Then again, for second output data block, we will discard this initial m-1 sample, that is initial 2 sample, as the value of m-1 over here is 2. So we will discard initial 2 samples, that is 2 and 10, we will discard it, and we will join 6 and 6. Then again we will discard the initial 2 samples and we will join the rest of the samples. So 4 and 10 is what we will join. Then again we will discard the initial 2 samples and we will join the rest of the samples that is left. So 2 and minus 13. Then again we will discard the initial 2 samples and we will join the rest of the samples, so -10 and 0. Again we will discard the initial two samples, that is 5 and 0, and we will join the rest of the samples, that is 7 and 6. And again we will discard the initial two samples and we will connect this 4 and -3. So this is how we find the final output by using the overlap safe method. Now try to solve this question by assuming that L is equal to 3 and L is equal to 4, and see whether you're getting the same answer or not. Thank you for watching the video. Please like and subscribe.